Okay, question 5, integration by substitution. Now, when you integrate using a substitution, you need to be very careful. This integral as it stands is all in terms of x. When we change the variable that we integrate with respect to, this dx means we're integrating with respect to x. As soon as we change that to integrating with respect to u, we have to change everything in this equation around so that it's all associated with u. So 0 and 1, our limits, for example, are associated with particular values of x. They'll need to change. X needs to be written in terms of u, 2x needs to be written in terms of u, and dx needs to be written in terms of u. So all of these are going to change. In order to work out how that change is going to come about, there's a few things that we do. First of all, we differentiate u with respect to x. And so if u is 2x plus 1, du by dx is 2. And then we do this weird thing where we separate the variables and you multiply this dx across. That's slightly odd. I'm not going to attempt to justify it, but we can say that du is equal to 2 dx. Or in other words, dx, which is the thing that we're going to replace after all, is equal to a half du. That's going to be important. So we can replace this dx with a half du. We're going to replace the 2x, but actually if u is 2x plus 1, it makes sense to replace this whole 2x plus 1 with a u. If we're replacing the x, sometimes you get lucky and this x will cancel because it'll turn out that du is equal to x dx, so you can replace all of x dx with a u, but in this case that hasn't happened. So we are going to need to replace the x. To work out what x is in terms of u, we rearrange this to make x the subject. So if u is 2x plus 1, it follows that 2x is u minus 1, and so x equals u minus 1 over 2. So we're going to have to replace that x with u minus 1 over 2. Finally, the limits, when x is 0, u is equal to 2x plus 1, so that means that u will be 2 zeros plus 1, or 1. And when x is 1, u will be 2 ones plus 1, so u will be 3. So we've done all the background work. We can now rewrite this integral as integral between u is 1 and u is 3 of x is u minus 1 over 2 over 2x plus 1, which is u, times dx, which is a half du. Now you're going to have to do some coughing, and you're going to have to do some working out with the fractions here, and this causes a lot of people problems. When you have a fraction within a fraction, the denominator of that fraction swaps sides effectively. So u minus 1 over 2, this 2 will now go to the bottom. You can justify that if you write it as u minus 1 over 2 divided by u. U as a fraction is u over 1. If you divide with fractions, you flip the second hand side, so that becomes u minus 1 over 2 times 1 over u, which means the result you get is u minus 1 over 2u. So that's what this becomes. But we can go one step further. If we're multiplying u minus 1 over 2u times a half, as we are here, then that 2 can go to the bottom as well, so we get u minus 1 over 4u. And let's bring the du in, because we always need to know what we're integrating with respect to. So now we're integrating u minus 1 over 4u. We're not done there though, because integrating quotient is not a simple procedure. However, if the denominator is not a sum, if there is a single term in the denominator, it's effectively saying that you're just dividing the top by 4u. That's a statement which doesn't mean much, but you could separate it out. So there's 1 over 4u times u minus 1. Why are we doing that? Because we couldn't really integrate this, but if we multiply this through, if we divide u by 4u and minus 1 by 4u, what we get, and I'm running out of space, is that 1 over 4u times u is just a quarter, and minus 1 times 1 over 4u is minus 1 over 4u. We are now getting somewhere. Still not done though. I'm now going to confusingly swing across to this side and carry on with this integral. So we are integrating a quarter minus 1 over 4u du between 1 and 3. Now, I've made a very, very important error here. I've written 1 over 4u as a quarter u. That's a common error. Or maybe it's not. No, there is a common error associated with 1 over 4u, but that's not actually it. 1 over 4u is 1 over 4 times 1 over u. And I'll write it like that because that avoids a common mistake, which is to write that as 4 times 1 over u. Anyway, that's as a quarter times 1 over u. When we integrate this, the integral of a quarter with respect to u is a quarter times u, so I'll put that u very clearly on top. Now, the integral of 1 over u is ln u. The integral of a quarter times 1 over u is a quarter ln u. I hope that you're happy with that. And again, between the intervals of 1 and 3. We can take out the factor of a quarter they have in the answer, so it would make sense to do that now. And we get a quarter u minus ln u between the intervals of 3 and 1. This now, if we apply our limits, becomes a quarter times substitute in 3 minus ln 3, minus substitute in 1 minus ln 1. Well, I think you know that ln 1 is 0, and 3 minus 1 is 2, so if we take all the numbers here, we've got 3 minus 1 minus 0 is just 2. And the only thing that's left is minus ln 3. And hello, we've got our answer. Magique.